Hello, everybody. This is a two-period lesson, a very important one. Today I can find t by taking the log of both sides, or y1, y2 intersect. Now I say finding t. We're going to also be finding p a little bit, but p is not a big deal. T is definitely a little bit more involved. So to get us started, we need to understand everything we've talked about so far in this unit. So let's hear our song. Here it is. Let's start from the beginning. Principal parentheses, 1 plus or minus the rate to the power of time. 5, 3, 500, yo. Principal parentheses, 1 plus minus r over n to the power nt. Compound for continuous. Converting rates 1 over n. Half-life raised t over h. Irregular. Converting rates raised 1 over n. Half-life raised t over h. Regular. All right, so I know I've been doing it in the past couple lessons, but we're going to do it again. I'm just going to sum up what everything means because we need to know when to use what. So I've got my songs right here. Let me just clean this up and kind of talk about it again. So my first verse. Principal parentheses 1 plus or minus the rates to the power of time. Divide the rate by 100. Yo, this is your basic, simple interest exponential growth decay formula. If you don't see compounding, if you don't see continuously, if there's not an irregular time, then we're using this formula. If there's compounding, then we use principal parentheses 1 plus minus r over n to the power nt. That's for compounding. But there's a second formula, and that's PERT. And we use PERT if it's being compounded continuously. So if it's continuously, there is no n. We use PERT. If it's compounded annually, monthly, quarterly, weekly, daily, then we use the n formula. Converting rates raise 1 over n. It's a pretty isolated lesson. That's not going to come up in today's lesson. But we did that lesson. It's pretty straightforward. When you convert rates, that's when you raise to the 1 over n power. Half-life raised t over h. Irregular. For half-life, we're raising to the t over h. Also for irregular time, if it's not half-life, if it's any irregular amount of time, we're raising to the t over h. So you have to know when to use what formula. So this is half-life, and this is irregular time. And again, by irregular time, instead of increasing by 5% every year, maybe I'm increasing by 5% every 3 years, or every 2.7 years, or some type of irregular amount of time. So again, if you see compounding, let me use a different color. You're using the n formula unless it says continuously, in which case you're using PERT. If it's half-life or in a regular amount of time, then the exponent instead of t is the t over h. If you don't see any of those things, if you don't see compounding, you don't see continuously, you don't see half-life, it's not irregular, then you're using this one. So now that we know when to use what, let's do it. Let's do some problems. I think I started by finding p, which is a lot easier, and then the bulk of this lesson is going to be finding t. Melanie's car is currently worth $22,000. She bought it 3 years ago, and the depreciation rate is compounded continuously. Compounded continuously. Per A equals P equals R equals T equals. Melanie's car is currently worth $22,000. She bought it 3 years ago. So 22,000 is not the initial value of the car, it's the value of the car after 3 years has passed. That's A. 3 years ago is T. The depreciation rate is 7%. Now with Hertz, if it's decreasing, it's going to be negative. So it's going to be negative 7 divided by 100, which is negative 0.07. For my regular formula, if it's decreasing, it's going to be minus. But for PERT, if the rate is decreasing, it's going to be negative. P is what we're trying to find. So 22,000 equals P, e to the negative 0.07 times 3. Now, I want to solve for P. So it's not too challenging. If I want to get P by itself, I'm just going to divide away e to the negative 0.07 times 3. E to the negative 0.07 times 3. I go to my calculator. Alpha y equals enter 22, 1, 2, 3 zeros over e second ln to the negative 0.07 times 3, and I get $27,140. With money, we generally want to round to the nearest cent, so that's 27,140.92. That's it. So we need to know which formula to use because it said compounded continuously. I know for that I'm going to use my PERT formula. I listed my variables, and since it wants me to solve for P, to get P by itself, all I had to do is divide away that E to the negative whatever it was. So I want you to try, well, let's start number 2 together, but then I want to have you try it on your own. Megan's savings account currently has 5,000, whoops, that's not the right button. Megan's saving account currently has $5,125 in it. If the account was opened 4 years ago and has an interest rate of 4.3% compounded weekly. Compounded weekly. Compounded, I use my N formula. Unless it says continuously, it doesn't, so I use my N formula. We list our variables. Why don't you take about 30 seconds right now? I'll just sit here, take about 30 seconds, and substitute those values in. And in order to do this lesson, you needed to have already done the regular compounding interest lesson. If you haven't done the compounding interest lesson already, then I would stop watching this and go back to that one before you do this one. So I'm just going to stay quiet for a few seconds, list your variables. Megan's savings account currently has 5125 in it. The account was opened 4 years ago. So 5125 is not the initial, it's what is left after time has passed. T is 4. The rate is 4.3%. Divide the rate by 100. Yo. Because it's compounded weekly, N is 52, and P is what we're trying to find. I want you to pause it. I want you to try to finish the problem off from here. Then unpause. Okay, now that you did it on your own, I'm going to go over it for you. 5125 is A. P is what I'm trying to find. 1 plus, because it's interest, it's getting bigger. 0.043 over N is 52 to the power of 52 times 4. I don't like what's in the parentheses. I always like to type it in first. 1 plus alpha y equals enter, 0.043 over 52. 1.0008 to the 52 times 4. And now to get p by itself, I'm just going to divide away that 1.008 to the 52 times 4 power. And that's just another reason I like to type that in first, because if I didn't, I don't know, I mean, this is ugly enough as it is. It's going to be even weirder to divide by this giant thing. So I just find this a little bit more organized. You can disagree with me. You don't have to do that step, but I find it better. So now I'm putting this whole thing. Oops, that didn't work. Oh no, is this going to give me an issue? So how about this way? Let's do 5125. Instead of copying and pasting, I can hit second answer. Then I'll take the previous answer to the power of 52 times 4. We're talking about money, so we're going to round to the nearest cent. 43, 15, 45. So to find p, you're just, subbing all the values like you normally would, and you're just going to divide away whatever is on the same side as p. Now, we're going to move into finding t, which is going to be more the bulk of this lesson. Number 4. Manny's savings account has a balance of $6,391.52. He opened the account with $5,500. 5.2% interest rate, compounded quarterly. That's what I wanted to see. That's telling me which formula I'm going to be using, because it's compounded and it's not continuous. It's my end formula. Principal parentheses 1 plus minus r over n to the power nt. So, I need to read carefully to see what each variable represents. Alright, so the difference between A and P is the issue that students often have a problem with. Manny's savings account has a balance of $63.91.52. He opened the account with $5,500. He opened it with $5,500. That is the initial value. After time has passed, the balance is $63.91.52. 5.2% interest rate. Don't forget to divide the rate by 100. Yo. Compounded quarterly, and is 4, and it's asking for t. So 63.91.52 equals 5,500. 1, it's interest, so it's plus 0.052 over 4 to the nt for t. Do what's inside the parentheses. 1 plus alpha y equals enter 0.052 over 4. 1.013. I already forgot what it was. Was it 1.013? Yes. Now, to solve this equation, it's a variable exponential equation. So, there are two options you're going to have. We can do the log of both sides, or we can do it graphically using y1, y2 intersect. I would rather everyone do the log of both sides. At this point, if you are comfortable solving exponential equations by taking the log of both sides, that's what you're going to do. If that did not work out for you, then we can also use our y1, y2 intersect instead. If you use your y1, y2 intersect method, you may not get full credit. But, if your algebra skills are lacking, it is a second option. So, let's do this algebraically first. My first step in solving an exponential equation, and you can go back to the video on that, solving variable exponential equations. is to isolate the base. So I divide both sides by 5,500. 1.013 to the 4t equals 6391.52 divided by 5,500. 1.16 dot dot dot. Once I isolate the base, which I just did, I now take the log of both sides. The reason I do that is because the exponent comes in front. And if you're not comfortable with this, again, you can go back to the solving variable exponential equations lesson. Now that it's in front, I'm one step from the end. I'm dividing both sides by 4 log 1.013. T equals alpha y equals enter. I'm doing log of the 1.16 thing. Oops, I think I hit it twice. Let me try that again. Log of that over 4 log 1.013. And there it is. It wants the answer how many years ago. So let's assume that it's saying to the nearest year. That would be 3 years. So what did we do? Because it was compounded quarterly, I wrote down the compounding formula, the N formula. I listed my variables. I substituted in. Once I did that, I chose to solve it algebraically. So your first step in solving a variable exponential equation is to isolate the base by dividing away the 5,500. Once I isolate the base, I take the log of both sides. That gets the exponent to come in front. I divide it away, and I get my answer. So if you're comfortable solving variable exponential equations, this really isn't bad. If you're not, then let's talk about how I would do this graphically. Let's bring it back here. If I want to do this graphically, y1, y2 intersect. Y equals 6391.52. Y2 5,500. 1.013 to the power of 4, and the variable that I put in is always x. I got that in the wrong spot. 4x. Let's delete this stuff up here. Now, I generally start with Zoom 6. I know Zoom 6 isn't going to work because I have these thousands, I know these values in the thousands. So I'm just going to go to Zoom Fit. Let's see if that gives me what I want to see. Yes, it does. I see the intersection. So I hit second trace, option 5. And of course, there's a video on this as well, a couple of videos on this. But this is the open response equation strategy. Enter, enter, enter. And you see here, there's your 2.9, which rounds to 3. So if you're using this strategy, as far as showing work goes, I need to see the y1, y2 intersect. That's you telling the grader what you're doing. Listen, I would rather everyone do it algebraically, but most importantly is that you're able to get the question correct. If it doesn't say to solve algebraically, you can get full points for using y1, y2 intersect. If it does say to solve algebraically, then you would get half of the possible points for that part of the question. All right, let's move on here. Number 5, a bank account was opened with $3,000. Interest is compounded continuously at 5.2%. How much time has passed if there is now $4,000 in the account? So I'm going to look at the continuous. I'm going to go to the continuous formula, which is PERT. I'm going to list A equals P equals R equals T equals. I want you to pause. I just want you to set it up. I don't want you to solve the equation. I just want you to set it up. So please pause, write down the values, substitute them in, and then unpause. Okay. Again, students often have problems with the difference between A and P. The bank account was opened with 3,000. Now, after time passes, there's 4,000. So A, your after amount is 4,000. It was opened with 3,000. That's your initial amount. The rate is 5.2. Don't forget to divide the rate by 100, EO. And T is what we're trying to find. So it's 4,000 equals 3,000 e to the 0.052 t. Now, from here, you need to solve the equation. So you can solve it algebraically by isolating and taking the log of both sides, or I would do the ln of both sides since there's an e, or you can do your y1, y2 intersects. I'm going to let you choose what you want to do. Again, I'd rather you do it algebraically with your isolating and log of both sides. But if you know that that does not work out very well for you, then you can do your y1, y2 intersect, and I will not give you a hard time about it. Either way, pause, solve the equation, unpause. Now that you've completed the problem, I will go over it for you both ways. Let's do it algebraically first. To solve an exponential equation, I isolate the base by dividing by 3,000. I believe when you type it into the calculator, you get 4/3 or 1.333333. And now that the base is isolated, I take the log of both sides. Now with e, I always like to do ln. Since ln of e is just 1, it just cancels out. If that confuses you, you don't have to do ln. You can just do log of both sides regular. I get 0.052t ln e. And again, the point is that ln e just kind of cancels out. If that confuses you, then, you can still put over ln e on both sides. It's just not going to affect the answer. So I'm going to go to my calculator. I'm going to alpha y equals enter ln 4/3 over 0.052. How much time has passed? Again, I didn't specify what's around to. That's my mistake. I should have told you what's around to. So we'll just assume we want the nearest year, and let's say 6 years. If I'm doing it graphically, then I'm doing y1, y2 intersect, y equals y1 is going to be 4,000, y2 is going to be 3,000 e to the 0.052, and instead of t, I put x. I'm not going to even bother with zoom 6 since I have thousands that are going on here. I'm going to try zoom fit. Zoom fit looks good. So I hit second trace, option 5, and whoops, I don't know what happened there. Let's try it again. Second trace, option 5. My calculator is being weird. Let me just click off for a moment. Second trace, option 5. Enter, enter, enter. And there's that 5.5 again. And again, with this strategy, it's always the x coordinate that the answer is. And you would get t equals 6. I'm just going to go through one more example with you. This is a long lesson. We're going to spend the whole block on this, or 2 periods on this if you're not in a block, or, if you're not even one of my students. It takes a long time to do this, to practice it. But there's really not much for me to show you here. They're all pretty much the same. It's just a matter of you practicing them. I just want to do one more. let's do number 13. One of the medical uses of iodine, I-131, a radioactive isotope of iodine, is to enhance X-ray images. Don't care. Half-life. So once I see half-life, I write down the half-life formula. Half-life raised T over H. So you see, it's really important that you know all your formulas. We talked about them all at the beginning. You need to know which one to use. You need to kind of have that written down or take a picture of it or a screenshot so you know which formula to use in which situations. The half-life is, you know what? Why don't you pause it? Why don't you fill in A equals P equals T equals H equals and substitute it into the formula and then unpause it and we can look at it from there. So pause, fill in the values, unpause. Okay, the half-life is approximately 8.02 days. That's H. It's pretty straightforward. It's saying that the half-life is that. That's the time it takes for the amount to be cut in half. A patient is injected with 20 milligrams, and then later it says how much time is needed for there to be 7 milligrams. So the question is, which one is P and which one is A? Which is the initial amount put into this guy's body? 20. 20 is P. That's the initial amount injected, and then after time passes, there's going to be 7 milligrams left. It's asking for T. So 7 equals 20, 1/2 to the power of T over 8.02. Now it's my job to solve it. So we can do it algebraically, we can do it graphically. I'm going to do it algebraically. It starts pretty much the same way, but there's one other little algebra twist that we're going to see, which shouldn't be anything new to you, but it's just, we haven't seen it in this lesson. So I always start by isolating. That gives me 7 over 20. I can leave it as 7 over 20 equals 1/2 to the T over 8.02. Next step, log of both sides. So I'm going to do log of 7 over 20. I'm going to do log of 1/2 to that whole thing. The exponent comes in front. I get log of 7 over 20 equals T over 8.02 log of 1/2. So now here's where the algebra is just slightly different. I don't like fractions, so to get rid of that fraction, I'm going to multiply both sides by the 8.02. That gets that to cancel. So I have 8.02 log 7 over 20 equals T log of 1/2. I would then divide both sides by log of 1/2. I'm going to type this giant thing into the calculator. Alpha y equals enter. 8.02 log 7 over 20 over log 1/2 to the nearest day is 12. So it's long. What was new for this one algebraically? Because I had a fraction in the exponent, when I brought the fraction out front, to get rid of that fraction, I multiply by the LCD. That's nothing new for us in this course, but we haven't done it, recently. That gets that 8.02 to cancel, and then I just solve it from there. Now again, if you don't have the algebra skills, then we go back to this step. and we do y1, y2 intersect. This was a Regents question, by the way. We'll take a look back in just a moment. So y1 is 7, y2 is 20. Whoops. 20 alpha y equals enter. 21/2 to the power of x over 8.02. So just double checking, everything looks good. Now, I'm not going to do zoom fit on this one because, the numbers aren't like crazy. I have 7, I have 20. I might need to adjust my window, but I'll start with zoom 6. And, yeah, it's alright. I feel like I need to see more of the top and more of the right. So I'm going to make my y max 20 and my x max 20. And let's see if that gives me a better picture. Looks good. Second trace, option 5. Move the cursor close to that point. Although, it doesn't technically, if there's only one intersection, it really doesn't have to be close to that point. You can put it anywhere. And there it is. To the nearest day, that would be t equals 12. Make sure if you're using this strategy, you are writing y1, y2 intersect. Does it say in this problem to solve algebraically? It says determine to the nearest day the amount of time needed before the amount, blah, 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 blah. Does it say to solve it algebraically? No. So what that means is you will get full credit for using your y1, y2 intersect strategy. If it did say to solve algebraically, then you would only get half of those points for that part of the question. So let me just see if there's an example of anywhere where it says algebraically in this packet. I don't even think I put anything like that algebraically. This was a 6-point Regents question. It doesn't say anything about algebraically, so you could have gotten, 6 out of 6 in this question just by, using your y1, y2 intersect. So to be clear, I would prefer that everyone is able to take the log of both sides. As a math teacher, I'm trying to teach you math. That's how you solve these equations algebraically. That being said, I understand the nature of my students, and for those of you who have really weak algebra skills and equation solving isn't really happening for you, you can also use your y1, y2 intersect strategy to get your answer. There's a lot of problems left for you to do. It's very important that you spend time on this lesson. It's a very important lesson. There's not much more for me to talk about, so I'm not going to talk about anything else. Your classwork/homework is going to be to finish this assignment. It's a long assignment. You should be spending a lot of time on this assignment, and you will be quizzed in it at the end. I hope everyone has a great day, a productive period, and a productive time with this lesson. Have a great day.